if you're human, you're asking yourself, why the heck do I need to even know this? Turns out in math and science, when we're working on things with repeated cycles or with circles, radian measures, a different way of measuring angles, turns out they're actually nicer to work with. So this is, I believe this is the first time you've seen this. So I'm going to explain what's happening here. Let's do it bright color. If I have a circle, which we do, I'm not going to draw on that again because it'll make it really bad. We know that if we take the distance from the center of the circle out to the circle, that's called the radius. Well, a radian, which is another way that we can measure an angle, and a radian is technically what happens if I take one radius and I pick it up. I wish I could pick it up off the paper, turn it into a string, and I plop it down right here on the circumference of the circle. The distance we get around the circle when we take one radius gives us a radian. So I have a radius here. I take that same exact length, I transfer it onto the circle, and that's the radian measure. Now, radians can be abbreviated RAD. A lot of times, though, when we're using radian measures, because we use them so much, we don't even write RAD. We just write the unit. So you're going to be kind of careful with that. If I'm going to convert between degrees and radians, which is the next thing I'm going to ask you to do, I'm going to multiply by fractions. Yay, fractions. Our magic fractions, depending on which way we're going, are going to be this pi radians over 180 degrees, or 180 degrees over pi radians. Now, this is really just using what we know. We're going to use unit multipliers. We love to multiply by 1. So what we're doing is we're multiplying by 1, but we're changing the way we're writing the 1 so that the top and the bottom of the fraction, whatever number I put up here on the top of the fraction and the bottom of the fraction, are the same distance. We've done that with 1 foot is 12 inches, all kinds of conversions. As long as we put the distances that represent the same thing on the top and the bottom of the fraction, we're multiplying by 1. Well, it turns out in radians and degrees, let's go to the color. If I draw myself a little unit circle here, turns out that pi radians, the circumference, if I go halfway around the circle right here, circumference, let's just say this radius is 1. We know the formula for circumference, I put it up here as a reminder, just in case you forgot, is 2 pi times the radius. The circumference, if I do a half a circle, well, the circumference, if I do a whole circle with a radius of 1, is 2 times pi times 1. That's a whole circle. But I only want half a circle, because I'm going to stop right over here. I'll show you why in a sec. So if I want half of that circumference, so here's algebra in action again. I'm going to do 1/2 of both sides of my equation. Half the circumference is going to be half of 2 pi. Half of 2 is 1. So it turns out in radians, or the circumference, if my radius is 1, right over here is pi. Well, you also know that if we rotate, and I like to take you back to your stunts, if you rotate a half a circle in stunts, that's called a 180, right? Because you just rotated 180 degrees. Well, this half a circle rotation is also 180 degrees. Those two values get me to the same point on that circle, so we can use those two values in our unit multiplier, and then we get to pick which way we want to use it, with the pi on the top of the fraction or with the pi on the bottom of the fraction. So really, you just have to remember one thing. You have to remember, if you're converting between degrees and radians, if you see this in your directions, you're going to be using either a 180 over pi or a pi over 180. And then you've got to figure out which one you need to use. You could memorize like it's written here, but I think it's easier to think through it and say, okay, well, I know, different color because I'm going to give you a little side example. If I multiply fractions, one of the rules of multiplying fractions is if I have, let's say, 3/7 times 7/4. If I multiply fractions, I always reduce if I can. Well, we reduce diagonally, top to bottom. So this 7 on the bottom of the first fraction is the same as the 7 on the top of the fraction. Those are going to turn into 1s. We want to use that to help us figure out what to multiply by here if I want to convert my 120 degrees to radian. So I'm going to start with what I know. It's already written on my paper, so I've got my 120 degrees written already. I'm going to multiply by 1, so I'm going to give myself parentheses with my fraction bar. Now I want the degrees to go away. If I want these degrees to slash out, then that means there's going to have to be a degrees on the bottom of this fraction that I use. And then I'm going to have, since I'm converting between degrees and radians, I'm going to put radians on the top of that fraction. So the fraction that I have to choose from is pi radians over 180 degrees, or 180 degrees over pi radians. Well, we just figured out we need the degrees to be in the bottom. So I'm going to put my 180 degrees on the bottom, my pi radians on the top, and then we get to work the fraction. I'm going to rewrite it again because I don't like that. The degrees are canceling. I'm going to plop a 1 under that 120. Now I see the 120 and the 180. Both of those have a 0 on the end, so I'm going to divide both of those by 10. That's going to turn this into 12 over 1 times pi over 18, yay, fractions. So now I see a 12 and an 18. Now, you don't have to get this all done in one. If you can think of the biggest number that goes into both of those, great. But you can also do it this way. If I see an even number on the top right here, this 12 is even, this 18 is even, I'm going to divide those by 2. I'm going to get a 6 and a 9. That's getting messy, so I'm going to rewrite it. 6 over 1 times pi over 9. Those, the 6 and the 9 are not even, but they can be divided by 3. So I'm going to divide by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So I'm going to have 2 over 1 times pi over 3. So now, I'm going to, once you get going on these, you'll take a few shortcuts, but I'm showing you all the steps just to make sure. So now I'm going to multiply straight across the top, straight across the bottom, and my conversion from 120 degrees to radians is going to be 2 pi over 3 radians. Now, we don't always write radians here, but since this is the first time through, let's write it just to make the point. So we converted from this 120 degrees up here to this 2 pi over 3 radians. That's your technique. So if I want to go over here in example B now, it's the same technique. I'm going to multiply by 1. The question is, am I going to put the pi on the top of this fraction, or am I going to put the pi on the bottom of this fraction? And when I put those in here, then I'm going to use 180 and pi. Now, yeah, we'll just call that good. So this negative pi over 12, don't let the negative scare you. Just treat it like it's a negative and carry it along the whole way. I need, what do I need? I need, technically, this is radians right here. We don't write it. So what I need to have happen is the radians need to cancel out, which means I need to have a radians on the bottom of this fraction when I do my multiplying. And you guys, I don't just do this for you. Every time I do this, that's exactly the way I think through it. And I even write the radians on it. Once I have the radians, then I know that the pi goes with the radians and the 180 degrees goes on top. So I'm going to take this to the next line down. I'm multiplying these two fractions. Pi is just a number. I see a negative pi on the top of the first fraction. I see a positive pi on the bottom of the second fraction. Now, when we cancel these, they don't just go away. They turn into 1. So this top of this left fraction is going to turn into negative 1. The bottom of my second fraction is going to turn into positive 1. And that's getting messy, so I'm going to rewrite it. I have a negative 1 over 12 times 180 over 1. I see a 12 and a 180. Those are both even, but 6 goes into 12 and 6 goes into 180. So I'm going to save myself a little bit of work and divide by 6. 6 goes into 18 3 times, and there's a 0 on the end, so that's going to be a 30 up there. So now I have negative 1 over 2 times a 30 over 1. Oh, but look, now I have 2 on the bottom is even, the